Hello, everyone. Today we will talk about vector databases and how they can be used. Learn what vector databases are, how they differ from regular databases, and why they are useful for working with artificial intelligence, and how to use them. So what are vector databases? It is a type of database that stores data in the form of vectors. Vectors are mathematical objects that have direction and magnitude. In the context of artificial intelligence, vectors are used to represent complex data such as text, images, or sounds in numerical form. Vector databases provide fast search and comparison of vectors, which is especially useful for tasks related to machine learning and natural language processing. They allow you to efficiently search for similar objects, which is very important for recommendation systems, classifications, and other similar tasks. They make sense when you work with large amounts of unstructured data, such as text documents. They are usually used when the amount of data exceeds a few thousand objects, but even for smaller amounts, they can be useful with their powerful search capabilities, which we will look at today by example. We will use the ChromaDB database. This is a popular vector database that provides highly efficient algorithms for searching and storing vectors. And it is easy to integrate with various programming languages. We will use it directly in the Node-RED environment. Node-RED is a visual programming tool that allows you to easily create flows for working with various services. Let's try now by example to see how a vector database works. For this, we will try to provide our own context. So let's now look at an example of how this works. Imagine a situation where we need to have our own assistant bot that should provide information about your newly created business. There is not enough information in general sources, and artificial intelligence does not know anything about it directly at the moment. In such cases, a vector database will help us to respond to the user according to their question. That is, we will now store an array of information about the company in a vector database, accordingly create a collection, save, and add vectors to it. After that, we will simulate the situation when a client asks a question about your business, and we will see what answers the vector database will return by performing a semantic search. Then this answer can be returned directly to your client, or it can be further processed using various artificial intelligence models to make the message more structured. So for this, in the Node-RED environment, we have three different flows built. The first flow is to create a collection, split the document into parts, create a vector using OpenAI models, and save this vector to Chroma. The next is to check our collection to ensure all information is saved. And the third flow is for data simulation. That is, we will simulate the situation when a client asks a question, for example, in a chatbot, and what the vector database will return according to the context that is saved and the user's question. Let's review the code. So, in the first function, where we create a collection and save a text document, we see that all we need to do is specify the MSG collection, the name of the collection. Next, we use the palette from our company, UBOS ChromaDB. And according to the documentation of the palette itself, we see that to create a collection, we need to pass the collection name, and we can optionally add some metadata, which we do not add in this case. Here it is important to configure only your connection, that is, specify the host of your database. I also deployed the database on UBOS platform and simply established a connection with this host by adding the HTTP and 8000 localhost. And I selected the operation. In this case, I need to create a collection. Next, to imitate a text document, I have a simple array of text written, and I divide this array accordingly by paragraphs into parts. Then I send these parts, each separately, for processing using the array loop node. Next, in this part of our flow, vector creation is performed. We take the key from OpenAI in the input according to the documentation of our palette as well. According to the documentation of our palette, we write the flow that is needed. MSG input is the text that will be processed by the embedding Ada model, and we assign an ID at this stage. When we receive a response from OpenAI and our vector is created, we save it. We prepare everything to save it. We use the ID response from OpenAI and save the plain text in the metadatas so that we can understand not by numerical expression, but by text what exactly we saved. And we duplicate the ID for convenience. And we send it to the Chroma palette as well, where we specify the add operation and also the connection to our host. And in this way, the loop will process each of these document parts and save them. Let's add debugs to see what the vector expression looks like. And we click the deploy button. We run our loop. It completed successfully. Our document was split into several parts. And let's see what the vector itself looks like. We open the response from OpenAI. And this is a numerical expression of our vector. It's something similar to coordinates. Let's check the information in the collection. That is, this flow is to simply get all the information that is stored in the collection. We look, here we just passed the limit 10, in which we have 6 stored, and pass the name of the collection that we created at this stage, specifying its name here. And we see that we get 6 objects returned and how our texts were divided. We see in the metadata. Well, let's try to simulate how the search will be performed. When we randomly return all vectors, our first vector starts like this. Let's try to send the question how to transform a business with UBOS for embedding here and see what will be returned. We call and look at this 9th debug, and in the metadata, the first result returned to us is the vector that is closest semantically to my question that I asked. We can also view the distance, that is, how close or far this and other answers are from the one we needed to return. So this is the shortest distance of this vector, that is, it is semantically the closest. Let's ask something else. For example, how to register. We compare the results, immediately look at the distance, and we see that here we got a response related to registration on the platform, so the semantic search is working. We can take this answer that comes first or second, or several first answers, or return it to the user directly, for example, providing information about your own business or any other situations, or we can send it to other artificial intelligence models so that it is somehow rephrased, modified, and return it to the user in that form. So today we have looked at what vector databases are, why they are useful for working with artificial intelligence, and how to use them in the Node-RED environment and, for example, the Chroma vector database, which is very convenient to do on the UBOS platform. I hope this video has helped you understand how to effectively work with vector databases in your projects. If you have any questions, leave them in the comments and subscribe to our channel so you don't miss new videos. Thank you for watching. See you.